Hello, algebra students. This is a lecture on 7.2, which is covering the properties of exponents, specifically the properties that involve quotients. In our previous lecture for section 7.1, we covered three different properties of exponents. All three of these properties involved multiplication in some capacity. One of the properties said that if you have something like the number a being taken to a power, and then you multiply that by that same base, it's still a being taken to another power. The way that we can simplify that is we add their exponents. I know this is a multiplication problem, but the way to simplify these exponents would be to add them together, and you would get a to the fifth in this example. Another one of the properties said if you have a being taken to the third power, and then that whole thing is being taken to the second power, in this example, you would multiply their exponents together and get a to the sixth. So notice the difference here. You have two bases that are being multiplied, then you add. If you have something being taken to a power being taken to another power, then you multiply them. And the third property discussed in section 7.1 is if you're multiplying two things together and both of them are being taken to a power, you could essentially what students call distribute that exponent to everything in the parentheses, and ab to the fourth power is the same as a to the fourth power, b to the fourth power. So these were the three properties from section 7.1. We are going to add two properties from section 7.2, and these properties are going to involve quotients. Now, quotients, of course, means division. So all these three examples had some sort of multiplication. A, B was being multiplied together. This is kind of a weird example, but when you break this up, this is the same as a to the third times a to the third because you're squaring something. So therefore, it's multiplying, and you can see the multiplication there. So all three of these have to do with multiplication. The new properties are going to deal with division. What our first property states is called the quotient of powers property. What our first property states is if you have something being taken to a power, and that is being divided by that same base being taken to another power. Okay, when you are dividing with the same base, you would subtract their exponents here and get a to the fourth. I have that broken up in words. To divide powers having the same base, okay, we got powers with the same base a and a, subtract their exponents, a to the fourth. Here's what it looks like algebraically. A to the m divided by a to the n is equal to a to the m minus n. And then I have another example here. 6 to the 7th being divided by 6 to the 3rd is the same as 6 to the 4th. Notice we kept the base as 6, but we subtracted their exponents. That was property number 1. Property number 2 states that if you have a fraction being taken to a power, much like if we had ab being taken to the 3rd, we would apply that 3 into both things, right? Here we have a fraction being taken to a power. You would apply this exponent to both the numerator and the denominator. This would be a to the 3rd divided by b to the 3rd. In words, when taking a power of a quotient, this is a quotient, it's a division, right? Take the power to the numerator and the power to the denominator. Here I have it algebraically. A divided by b to the nth power is the same as a to the nth power, b to the nth power. And here's an example. If 2/3 was being taken to the 4th, that's the same as 2 to the 4th divided by 3 to the 4th. We took that exponent and we applied it to both the numerator and the denominator. So you guys are going to be responsible for putting all of these properties together. All the properties individually isn't very difficult, but it does get pretty difficult when we are using multiple of them at a time. This first example here, -3 to the 9th power divided by -3 to the 3rd. I just want to talk about negatives and exponents. If I want to write the number 3 to the 3rd power, let's say, I can just write 3 to the 3rd power. But if I want to take the number -3 to the 3rd power, I have to be putting it in parentheses. These parentheses are there to just signify that -3 is the number being taken to the 9th power. And then the denominator is saying -3 is being taken to the 3rd power. These have the same base, so we would subtract their exponents, and our answer would still be -3 in parentheses to the 6th power. If you did not have those parentheses there, you would be wrong. It actually would be a different answer. So please be careful with those parentheses. Remember, I can just write 3 to the third power. It doesn't need parentheses. But if a negative number is being taken to an exponent, it needs those parentheses. Otherwise, it says something different. Second example, I have 1 divided by y to the 5th, and that's being multiplied by just y to the 8th. We're going to have to utilize some of our previous knowledge of how to multiply a fraction by another number. What we like to do is we like to make them both fractions, and then multiply the numerators across and multiply the denominators across. So this would be 1 times y to the 8th, because that's the numerator here, right? Which would be y to the 8th. And then y to the 5th times 1 would just be y to the 5th. Subtract their exponents now. They have the same base. They're being divided, so you would subtract their exponents and get y to the 3rd. We do have some more difficult examples here. This example here is a weird one, and I know there's one in your homework like it. So basically what I do is I take this negative sign. This is a reminder. Negative 7 divided by 6 is the same as negative 7 divided by 6. Sorry, I don't know why I'm saying 6. X is the same as 7 divided by negative x. All 3 of these statements are the exact same. It doesn't matter if the negative sign is out front, with the denominator, or with the numerator. It should not be with both, though, because that would be something different. So, which of these would I like to utilize the most when I have this problem? It actually makes a lot of sense to use this one. So if I write this, remember the exponent has to be applied to both the numerator and the denominator. I could write this as negative 7 to the 2nd over x to the 2nd. And now depending on the section of the homework that you're dealing with, it might say simplify your exponents completely. If that's the case, you know what negative 7 to the 2nd power is. You can actually do that problem. Negative 7 times negative 7 would just be 49, right? And then you'd be dividing that by x squared. Some of the questions in your homework are going to say simplify your exponents completely. Some of your homework questions are going to say leave your answer in exponents. So if I was leaving my answer in exponents, this would be the answer. If it said simplify your exponents completely, that means, hey, I can do this with my calculator or in my head, right? Then I would be looking at this answer. Next example, I have x to the 2nd being divided by 4y, and all of that is to the 8th power. The second property that we studied today says that we need to take this exponent and apply it to the numerator and the denominator. Well, from the previous lecture, if you have x being taken to the 2nd power, and then that's being taken to the 8th power, that tells you to multiply those exponents together, and you'd get x to the 16th. And then our denominator would be either 4y to the 8th you might have, or y in parentheses being taken to the 8th. But remember, a property from last class period, the 7.1 lecture, said that exponent needs to be applied to both everything in the parentheses. It needs to be essentially distributed to everything there. So this would be x to the 16th over 4 to the 8th, y to the 8th. And that would be a good answer if my question said simplify your exponents or leave your answer in exponents. If it said to simplify your exponents completely, I would need to get what 4 to the 8th is, but that's going to be a very large number. A couple more examples, and then we'll wrap it up. So in this example here, this exponent outside the parentheses needs to be applied to everything. It needs to be applied to the 2, the s, the 3, and the t. That would give me 2 to the 3rd, s to the 3rd, over 3 to the 3rd, t to the 3rd, all being multiplied by t to the 5th over 16. Now, I'm just telling you this right now. If this was the question, I would probably say to simplify your answer completely. this was the question that would be more likely what I'd ask, because all the exponents of numbers are kind of small. Here's 2 to the third, or sorry, 2 to the third, 2 to the third is 8, s to the third, t to the fifth. Remember, what I'm doing here is if you have a fraction being multiplied by a fraction, you can just multiply across. And multiplying just means basically write them next to each other. Moving on to the denominator, 3 to the third is 27 times t to the third times 16. You could actually do 27 times 16 here, and then do 8 divided by that. I'm actually going to simplify things here. 8 in your numerator and 16 in your denominator can just simplify to 1/2. So this would be 1 times s to the third times t to the fifth. So s to the third, t to the fifth would be my numerator. And my denominator would be 54, because 27 times that 2, t to the third. I'm still not done yet. One of the properties states that if you have the same base, t being in the numerator and t in the denominator, you can subtract their exponents, right? T to the fifth divided by t to the third. If it was just that, if this all was gone, you'd say, hey, subtract those exponents. You're going to do the same here. And when you subtract them, whatever you get goes in the numerator. So this would be s to the third t squared over 54. And then this last example, this 3 needs to be applied to everything. 4 to the third, x to the, what are you coming up with? Hopefully you're coming up with 6 here, because you would multiply those. 5 to the third, y to the third. If it said simplify your exponents completely, you could go on. But if it just said write your answer using exponents, nothing in here can be simplified. Nothing has the same base, 4, x, 5, and y. None of it's the same. So that would be a good answer. Otherwise, 4 to the third is 64. And 5 to the third is 125. And that would be the other answer if it said simplify your exponents completely. That's all I have for you guys today. This is section 7.2 on exponent properties that involve quotients.